today I'm going to discuss about the basic displacement time graph, which in each and every case, like displacement time graph, details slope and everything. When we encounter zero velocity, the constant velocity, where we say that it's not zero, it's constant, each and everything that we're reading here as well. So displacement, and it's very informative video. Displacement time graph. So let's proceed it further. So the first graph that I'm going to discuss with you guys is just a simple graph. For example, the explanation that I'm going to give you here is that, for example, for a while, consider that this is a graph. Okay, this is a graph of displacement time graph, and we know that the displacement time graph is something like this: time present on the x-axis and displacement on the y-axis. And here, from here we draw the line, like line something like this, and a lot of lines we have drawn from the origin or position vector, we could say that. So this is something like this, right? So from here we're gonna draw the theta here, theta 1. For a while you can name it as a theta 1, you can name it as theta 2, or you can name it as theta 3. That's totally your will, right? So this is theta 2, and so on. For this part is a theta 3, and so on. Yeah, so this is basically a simple graph. So what I want to conclude it here is that the this point is actually known as, I could say that this is a slope. Yes, slope. And the theta here represents the slope. This theta here represents the slope. So theta is equals to slope. This theta represents here, and the represent here the slope. So as the theta increases, as you can see here, so slope increases. Theta here representing a slope, as the theta increases and slope increases, right? So theta in real is known as 10. Theta is equals to 10. In real, theta is equals to 10, right? Theta is equals to 10, and in actual these lines, which is these lines, represents velocity. This line represents velocity in real. So the slope of this displacement time graph represents velocity, right? So this is the first case that I'm going to discuss here. So what's the formula of theta or slope? So we have a very simple formula for the theta and slope. So let's write it here, which is theta is equals to y2 minus y1 x2 divided by x2 minus x1. Or as we can see here, the theta y2 is displacement, which means s2 minus s1 divided by t2 minus t1, something like this, because we know that what's present in axis and what's present in y-axis. So this is something like this, the little introduction about it. In reality, slope is equals to 10 theta, and now we're going to deal with the numericals here, and the actual practical portions that we're going to see here, so they'll be easy for you to understand it, right? So let's erase it. There's a redundant stuff written here for a while, right? So let's erase it as well. Okay, so let's proceed. So for that I need a marker. Yeah, it's perfect, right? So let's draw a graph here. So first of all, I'm drawing it. Let's take a while to draw. So for that we can discuss anything, like what graph I'm gonna make here is that it's a displacement time graph, which represents the first of all decreasing velocity, then the constant velocity, and yet again we'll be discussing about the this is decreasing, but in a way that I'm going to show you here. But for a while, if we're going to only consider this as a graph, so I'm going to discuss about the negative graph as well. So firstly, let's deal with it because that's basic. So before moving ahead to discuss the advanced, we don't need to discuss the basics here, right? So this is something like that. It's taking a while. So for that, we can have patience, right? So it's almost just done. So let's take a light marker so it will be prominent when I write it. Right. So for example, this is displacement. Not example for example, but it's for here, like it's displacement. It's time. For here, its value is 20. For here, we have a value 15. And here, OMG, it's just child. I'm gonna do that. I'm gonna write it again. Okay. So let's write a 15 here again. Size. Okay, it's 15 for a while is considered 15. So this is 10 and this is 0, right? This is A, this is B, yeah, and this is C, and this is 10 and 15. 10 and 15. So this is a complete information that I have written here. So let's take a new marker for explaining. First of all, I'm going to talk about O and A. Let's talk about now. First of all, I'm going to talk about O and A. What O and exactly mean here, right? So let's talk about it. If we talk about the slope of O and A, it's something slope formula we are aware of it, which is y2 minus y1, y2 minus y1. OMG, it's just clicking here. I don't know what's happening to my mouse. Okay, y2 minus y1 x2 minus x1, right? That's pretty obvious. I have just told it in the previous video. We talk about y2 here. We considering O and A. Y2 is here is 10, but y1 here is 0. Okay, y1 is 0. If we talk about x2, it's x2 here is it's yet again it's 10. Yeah, it's 10. And yeah. So this slope of O and A is 1, which means it represents that it is increasing. This slope represents that it's increasing here in a way. Okay. So if we talk about the other one graph here, which is O and A, it's positive in nature.